Okay, dear students. Now today let's have a discussion about the classification of substances based on their chemical nature. In earlier classes we have understood that substances are grouped together based on their physical properties like roughness, lusterness, transparency, solubility, or whether it floats or sink in a liquid, etc. But in this chapter, we will try to classify all the substances into acids, bases, and salts based on their chemical nature or properties. Here, in this classification, we have three different groups. That is, we are going to discuss about the acids, bases, and the salts. That is, now let's try to understand what are acids, what are bases, and what are salts. So here in this chapter, substances, when we test them, may have some sour taste, some may have bitter taste, some may be tasteless. And in everyday life, we also come across substances like which have sour taste. That is like lemon, mango, grapes, orange, amla, etc. They have sour taste. Such substances which have a sour taste by nature, we'll classify them, we will group them into acids. That is, acids are the substances that have a sour taste. That have sour taste. That is, these are the substances that have a sour taste. Example, we can give lemon juice, or you may give orange juice, amla, etc. because they have sour taste. And these acids can be further grouped into two types. That is, here we can group acid into inorganic acids. The first one inorganic acids, and the second one organic acids. Then what are organic acids, or what are the inorganic acids? Here, when you read this, you will find it in organic acids. They are the substances, they are the acids which are prepared from mineral substances. That is, here these acids which are prepared from mineral salts, they are called inorganic acids. And those acids here, the second one, organic acids, these are the acids which are usually found in the living plants or animals. For example, you have citric acids which are found in lemon, and orange also you will find citric acid, and in many living organisms like in ants you can find formic acids. That is, this acids which are obtained from living source, they are called organic acids. And those which are prepared or synthesized from minerals, they are called inorganic acids. Example, you can give hydrochloric acid or sulfuric acid, and you can give also nitric acid. Hydrochloric acid, its chemical name is hydrogen chloride, sulfuric acid, hydrogen sulfate, etc. So acids which have sour taste are grouped into two. That is number one, inorganic acid, and number two, organic acids. These are about the acids. You can give many examples. Not only these substances which have a sour taste, we also have other substances which have bitter taste. That is, for example, when you taste baking soda or soda bicarb that you use at home for cooking uti, when you taste that, you will feel a bitter taste. And such substances which have bitter taste, they can be called as bases. That is example of base. You can give washing soda, baking soda, etc. This one here, you can define it like this. Those substances that have a bitter taste can be called base. This one, this second one. And some other substances may not have any sour or bitter taste, but may be the product of the neutralizing reaction between an acid and a base, and such substances are called salt. That is, salts, they are neutralization product of acid and bases. They are neutralization product of acid and bases. Here you can write it like this. This is what is neutralization. It is a process of cancelling the properties of each of the acid with the base or a base with an acid. That is, when you mix acids and bases together, they will produce a neutral substance plus water, and may evolve some heat also. That is, when you mix an acid with the base, you can get a salt and water. Here heat is produced in this reaction. It is kind of reaction and also called neutralization reaction. When you add the base to an acid or an acid to a base, they will try to cancel the properties of its other, thereby forming salt. This one, salt. And water also is produced in this reaction. For example, you can say, take the example of the reaction between hydrochloric acid and sodium hydroxide. For example, hydrochloric acid, the formula is HCl plus sodium hydroxide, which is a base, NaOH. That is first one. This is hydrochloric acid, a mineral acid, and this one is sodium hydroxide, a base, a substance which have a bitter taste. When you react these together, that is when you put sodium hydroxide into HCl, hydrochloric acid, what you will get is a salt called sodium chloride, plus along with this water, H2O, is reduced, and heat may be evolved in this reaction. Heat is evolved, it is produced in this reaction. This sodium chloride is nothing but it is the common salt that we use in our cooking, and this is the water that we drink. So in this way, salt is produced. This one, this is the salt called sodium chloride, and also commonly known called as common salt. And this process this reaction, this is called neutralization reaction. Neutralization reaction. So in this way salts are formed. And about this, after this, now we can discuss some of the chemical properties of the acids, that some useful nature of the acids. We use acids in our car batteries, in our inverter batteries also. They can be used to manufacture fertilizer, plastic products, etc. And some may be used in cleaning dirts from metal surfaces, etc. That is uses of some acids have many uses, but as in your book, some uses may be mentioned here. That is, for example, sulfuric acid. This sulfuric acid, H2SO4. The formula is H2SO4. This sulfuric acid can be used. It is used. They are used in car batteries. In our inverter batteries also, we have lead accumulator battery, and in that battery we put acid, and that acid is nothing but sulfuric acid. And hydrochloric acid, this one is also used to remove dirt from the iron or steel surfaces. And another important use is nitric acid, and they are used in the production of explosives, in the production of fertilizers, and in many other, say for example in the cleaning solution of dolls. By the goldsmiths, they use aquaresia, which is a mixture of nitric acid and shell. So in this way, these are some useful nature of the acids that we use in our everyday life. And after this, let's have about the indicator. What are indicators? They may be natural or they may be synthetic. That is, they are the substances which we usually use to test the acidic or basic nature of a substance. That is, indicator, they are the substance used to test whether a substance is acidic or basic. And then this indicator may be of natural origin, this one, first one, natural indicator, or it may be of synthetic, that is chemically prepared in the labs. So natural indicator, we have many examples. The turmeric powder that we use in our cooking, it is also kind of natural indicator. The liquid obtained by crushing cyanurose flower or any colorful flowers, they can be used as indicator. And among the examples of synthetic indicators, we have phenolphthalein, methyl orange. Whether a substance or a solution or a liquid is acidic or basic, that is, with this substance we try to detect whether a substance, we try to find out whether a substance given to you is an acid or a base. It is without testing. It is dangerous to test without any substance given to you. So we have to use this indicator in order to find out a clear solution given to you, whether it is acid or a base. So indicators are very, very useful in detecting the nature of the substance, that is, whether a substance is acid or it is a base. Now after this, let us have an activity about the use of this indicator to find out the substance given to you is an acid or a base. For example, here you take a beaker. For this experiment, for this activity, you have to take a beaker. I have drawn the diagram earlier. So in this beaker, let me make it layers. You take some acid. For example, you take hydrochloric acid into this beaker. That is, HCl is taken in this beaker. Dilute solution of hydrochloric acid is taken into it, and you put a drop of phenolphthalein here. Phenolphthalein indicator. Phenolphthalein. You check the spelling in the book. I have no space to write the spelling. So you put a drop, 1 or 2 drops of phenolphthalein into this beaker, and you see what is the color. It is colorless. In the acid, phenolphthalein is colorless. When you put phenolphthalein in an acidic solution, the solution will be colorless. There is no coloration in the solution. Then after putting phenolphthalein into this beaker, then you add a base. For example, you take, say, sodium hydroxide, NaOH, sodium hydroxide. You put it into the beaker drop by drop while stirring it. With the stick, you stir the solution in the beaker. At the same time, you put sodium hydroxide drop by drop, and you continue adding sodium hydroxide, and at a certain stage, by just 1 drop of the sodium hydroxide, the solution will change its color into pink. That is, here in the next diagram you see the pink coloration. That is, after adding sodium hydroxide drop by drop, the hydrochloric acid solution inside the beaker goes neutralizing. That is, its properties being cancelled by the properties of the sodium hydroxide. That is, the solution of acid is being neutralized. At a certain stage, when sufficient amount of sodium hydroxide is added into the beaker, this solution inside the beaker becomes neutral. That is, there is no acidic or basic properties. So after that stage, if you add 1 more drop of this sodium hydroxide, into this beaker, then the solution of this liquid inside the beaker will just change to pink by just 1 drop of sodium hydroxide. That means now the solution just becomes basic. That is, before adding sodium hydroxide, the solution inside the beaker is acidic, and after adding sodium hydroxide drop by drop, the hydrochloric acid is being neutralized gradually, and after certain stage, the whole of the hydrochloric acid inside the beaker is totally neutralized. And after that, we add 1 more drop of sodium hydroxide, then the solution inside the beaker will just become basic, and it is indicated by the phenolphthalein indicator. You have put a phenolphthalein indicator inside the beaker, so the color of phenolphthalein just changes to pink color when the solution inside the beaker just becomes basic. So in this way, indicator, phenolphthalein indicator is used whether a solution is acidic or basic. That is, when the solution is acidic, the color of phenolphthalein is colorless. Here this is colorless. This solution is colorless. And here this solution is pink in color. That is, when the solution just becomes basic, the color of the phenolphthalein changes to pink. So in that way, indicators are used to test the nature of the substance, whether it is acid or basic. So this is all about the discussion about these acid, bases, and salts. And you also read the book that is the lesson on chapter 5 very carefully, and you try to listen and understand what is written in the book by listening to this. And that's all for today. In the next video, let's have another lesson. Okay, so thank you. Thanks.